Hello students, and welcome to the lecture on Role of Telecommunication in Information Technology. After this lecture, we will be able to learn the following objectives. Understand the information and the channel capacity. Explain classification of channel capacity. Define the concept of signal-to-noise ratio. Discuss baseband channels and modulated carriers. Explain communication network. Define transmission through wires, cables, or fibers. Understand the telephone system. Discuss wireless communication. Explain satellite communication. Let's start with a brief introduction to communication. Communication is a process in which information is transferred from source to destination. Information can be in any form, for example, voice, data, video, graphics, etc. Voice communication is the simplest mode of communication. People also use facial expressions and body language to communicate with each other. Basic communication system elements are transmitter, receiver, medium. Terrestrial, for example, cable, coax, wire, etc., and extraterrestrial, for example, radio waves.
The sender is the individual group or organization that needs or wants to share information with some other individual group or organization. The receiver is the individual group or organization for which the information is intended. The message is the information that the sender needs or wants to share with other people. A message is clear when it contains information that is easily interpreted or understood. Once the sender has decided what the message is, the next step in the process is encoding, translating the message into symbols or language that the receiver understands. Once a message is encoded, it is transmitted to the receiver through some medium. The medium is the pathway through which an encoded message is transmitted to a receiver. Just as senders have to translate their ideas or messages into a form that can be to the receiver, receivers have to make sense of the messages they receive. Decoding is interpreting, or trying to make sense of a sender's message. After decoding the message, the receiver has to respond to it, and start the feedback loop. The receiver must first decide what message to pass on to the original sender. If receiver properly interpreted the initial message, and common understanding has been reached, the communication process is complete.
Purpose of a communication systems are deliver as much information as possible from the source to the destination, capacity. Capacity may be measured in bits per second, BPS, or in call capacity. Information may be of different natures, such as voice, video, or data produced by a computer. Deliver information in shortest time, delay. Delays are measured in milliseconds or in round-trip delay. Reduce errors in delivery of information, error detection correction. Errors can be measured as bit error rate, or BER, or frame error rate, FER. Now let's study information and the channel capacity. Data that is accurate and timely, specific and organized for a purpose, presented within a context that gives it meaning and relevance, and can lead to an increase in understanding and decrease in uncertainty is known as information. Information is valuable because it can affect behavior, a decision, or an outcome. For example, if a manager is told that his or her company's net profit decreased in the past month, he or she may use this information as a reason to cut financial spending for the next month. A piece of information is considered valueless if, after receiving it, things remain unchanged. Information, how do we represent it? Representation information is any information required to understand and render both the digital material and the associated metadata. Digital objects are stored as bit streams, which are not understandable to a human being without further data to interpret them. Representation information is the extra structural or semantic information which converts raw data into something more meaningful. Representation information should contain as much structure and semantic information as is required for a defined community or designated community in OAIS terminology to access the information stored within a digital object. Digital and analog, what are they? There are two ways to represent information. Information that is continuous, that is, any piece of information that can take on any of an infinite set of values, is said to be analog. Digital information is restricted to a finite set of values. For example, a traffic light normally is red, yellow, or green. Computers use a form of digital information called binary information. Here the information is restricted to only two values, 1 or 0. Now we will study the other classification of channel capacity. Let's look at two major categories of embedding mechanisms that are practically realizable. We shall begin with simplified models and then gradually loosen the assumptions to consider practical situations. The capacities achievable by the two types of schemes are compared, from which the conditions under which each type of schemes is superior to the other one is identified. We consider the following problems and purpose solutions. Distortion during and after embedding. Depending on applications, the allowable change introduced by embedding may be smaller, sometimes much smaller, than a distortion introduced to the watermarked image. Actual noise conditions. An embedding system is generally designed to survive certain noise conditions. This single robustness capacity trade-off has limitation in practical applications. In the role of telecommunication in information technology environments, the actual noise condition may vary dramatically. Second, a watermarked image or video may be compressed or transcoded to a different bit rate in order to be delivered through different kinds of communication channels. On-stationary property. Due to the non-stationary nature of perceptual sources, the amount of data that can be embedded varies significantly from region to region. This uneven embedding capacity adds difficulty to high-rate embedding, especially in practical systems that need to accommodate diverse multimedia content. Frequency domain representation of signal. Signals can be represented by a magnitude and phase as a function of frequency. Signals that repeat periodically in time are represented by a power spectrum. Signals that are time limited, for example, are only non-zero for a finite time, are represented by an energy spectrum. One reason why data cannot be transmitted at an arbitrary rate. Digital transmission is the sending of information over a physical communications media in the form of digital signals. Analog signals must therefore be digitized first before being transmitted. However, as digital information cannot be sent directly in the form of zeros and ones, it must be encoded in the form of a signal with two states. Did you know the world's first wireless telephone conversation occurred in 1880 when Alexander Graham Bell and Charles Sumner Tainter invented and patented the photophone? Now we will study the concept of signal-to-noise ratio. In analog and digital communications, signal-to-noise ratio, often written SN or SNR, is a measure of signal strength relative to background noise. The ratio is usually measured in decibels, or dB. If the incoming signal strength is microvolts, which is Vs, and the noise level, also in microvolts, is Vn, then the signal-to-noise ratio, Sn in decibels, is given by the formula as shown here. Signal smoothing algorithms. The signal-to-noise ratio, SNR, of a signal can be enhanced by either hardware or software techniques. Some of the more common signal smoothing algorithms are moving average algorithm. The simple software technique for smoothing signals consisting of equidistant points is the moving average. Savitsky-Golay algorithm. A much better picture and procedure than simply averaging points is to perform a least squares fit of a small set of consecutive data points to a polynomial and take the calculated central point of the fitted polynomial curve as the new smooth data point. Ensemble average. In ensemble average, successive sets of data are collected and summed point by point. Therefore, a prerequisite for the application of this method is the ability to reproduce the signal as many times as possible, starting always from the same data point. Now we will study baseband signals and modulated carriers. Signals are categorized as baseband or broadband, depending on whether the transmission uses the entire capacity of the media to transmit data over a single channel, or divides the data into multiple channels and sends separate streams of data over each channel. Baseband is the simpler of the technologies because only one signal goes over the cable at a given time. Baseband signaling is usually associated with digital technologies, but it can also be used with analog technologies. Modulation techniques overview. One of the fundamental aspects of any radio communications transmission system is modulation, or the way in which the information is superimposed on the radio carrier. Amplitude modulation, AM. This form of modulation involves modulating the amplitude or intensity of the signal.
What is amplitude modulation, that is AM? When the amplitude of high-frequency carrier wave is changed in accordance with the intensity of the signal, this process is called amplitude modulation. In the amplitude modulation, only the amplitude of the carrier wave is changed. The frequency and the phase of the carrier wave remains constant. The first visual shows the principle of amplitude modulation. The diagram also shows the audio-electrical signal of frequency Fs. The second visual shows a carrier wave of constant amplitude with frequency Fc. The third visual is the amplitude modulated wave. It is to be noted that the amplitudes of both positive and negative half cycles of carrier waves are changed in accordance with the signal. Thus, the amplitude of the modulated wave possesses the frequency of audio signal waves.
Frequency modulation, FM. This form of modulation varies the frequency in line with the modulating signal. Phase modulation, PM. Phase modulation varies the phase of the carrier in line with the modulating signal. Phase modulation and frequency modulation have many similarities and are linked. One is the differential of the other. However, phase modulation lends itself to data transmissions, and as a result, its use has grown rapidly over recent years. Modulation schemes. Modulations are the techniques to carry digital data over analog waveforms. Carrierless amplitude modulation, phase modulation, CAP. CAP is a bandwidth-efficient two-dimensional pass band line code derived from QAM by AT&T Bell. Code division multiple access, CDMA. CDMA is a form of spread spectrum transmission, which works by coding and spreading the information to be transmitted over a wide band. CDMA is asynchronous and typically uses a 30 MHz bandwidth. Coded orthogonal frequency division multiplexing, or COFDM. COFDM is an experimental approach intended for broadcast TV, which works by taking the transmitted data and spreading it over a large number of carriers, rather than modulating it all into a single carrier. Quadrature amplitude modulation, QAM. QAM systems combine PSK and ASK to increase the number of states per symbol. QAM is a proven technique for the transmission of digital data over a wide range of channels, from voice band modems at 9600 bps to microwave links transmitting hundreds of Mbps. Quadrature phase shift keying, QPSK. QPSK has been selected by DAVIC as the upstream modulation format and is the current frontrunner for selection by the IEEE 802.14 committee. QPSK is also used in many satellite systems. Vestigial sideband, VSB. VSB is the major competing modulation technique to QAM for downstream transmission on HFC. QAM and VSB comparison. Both modulations are bandwidth efficient and use multiple signal levels to send multiple bits per hertz. VSB conserves bandwidth by only transmitting a single sideband of the modulated RF spectrum, while QAM conserves bandwidth by sending two orthogonal sine and cosine carriers in the same frequency band. Modulation and testing. A cable system will probably have to manage program material transported in different digital video formats. This presents a myriad of electronics testing issues to the head-end system operator. Modulation and filtering. While an FCC channel is defined as having a 6 MHz bandwidth, the edges of this are often not used in order to provide space between channels and to avoid interference. We shall now talk about the communication network. Communication networks based on serial data transmission are the platform of up-to-date automation systems. Classification of communication networks. Depending on the application, i.e. manufacturing, process, office, or building automation, the communication tasks to be performed vary in complexity and are sometimes even contradictory. A quite general classification criterion is the distance over which communication takes place. There are local networks, LANs, local area networks, as well as widely distributed networks, WANs, wide area networks. Communication media. Some of the earlier methods used for communication have been visual and audio in the form of gestures, sound, and pictures drawings. Technology today has transformed these sounds and gestures to produce speech, videos, films, posters, and theater. Now let us learn about transmission through wires, cables, or fibers. Fiber optic cable keeps becoming more popular as it increasingly becomes more cost-effective and more widely understood. A common application for fiber with IQ is to extend the IQ bus data loop on long runs between equipment rooms. The three basic elements of a fiber optic cable are the core, the cladding, and the coating. Fiber size. The size of the optical fiber is commonly referred to by the outer diameter of its core, cladding, and coating. Fiber type. Fiber can be identified by the type of paths that the light rays or modes travel within the fiber core. There are two basic types of fiber, multimode and single mode. Multimode fiber cores may be either step index or graded index. Design considerations. Considerations of tensile strength, ruggedness, durability, flexibility, size, resistance to the environment, flammability, temperature range, and appearance are important in constructing optical fiber cable. First level of fiber protection. The optical fiber is a very small waveguide. In an environment free from stress or external forces, this waveguide will transmit the light launched into it with minimal loss or attenuation. Telephone wires. The basics of the wiring are pretty easy to understand. Most telephone wires are one or more twisted pairs of copper wire. The most common type is the 4-strand, 2-twisted pair. XDSL technology. DSL is a digital broadband transmission technology that involves sending digital information over a subscriber's telephone line, also referred to as the local loop. Optical communication. Optical communication is any type of communication in which light is used to carry the signal to the remote end instead of electrical current. Now let's study the telephone system. A phone system comprises multiple telephones used in an interconnected fashion that allows for advanced telephony features such as call handling and transferring, conference calling, call metering and accounting, private and shared voice message boxes, and so on. A telephone system can range from just a few telephones in a home or small business up to a complex private branch exchange, or PBX system, used by mid-sized and large businesses. Now let's study wireless communication. Wireless communications is, by any measure, the fastest growing segment of the communications industry. The vision of wireless communications supporting information exchange between people or devices is the communications frontier of the next few decades, and much of it already exists in some form. Wireless networks will connect palm-top, laptop, and desktop computers anywhere within an office building or campus, as well as from the corner cafe. In the home, these networks will enable a new class of intelligent electronic devices that can interact with each other and with the Internet, in addition to providing connectivity between computers, phones, and security monitoring systems. Such smart homes can also help the elderly and disabled with assisted living, patient monitoring, and emergency response. Wireless entertainment will permeate the home and any place that people congregate. Video teleconferencing will take place between buildings that are blocks or even continents apart, and these conferences can include travelers as well, from the salesperson that missed his plane connection to the CEO off sailing in the Caribbean. Wireless video will enable remote classrooms, remote training facilities, and remote hospitals anywhere in the world. Wireless sensors have an enormous range of both commercial and military applications. Commercial applications include monitoring of fire hazard, hazardous waste sites, stress and strain in buildings and bridges, carbon dioxide movement, and the spread of chemicals and gases at a disaster site. Finally, wireless networks enable distributed control systems with remote devices, sensors, and actuators linked together via wireless communication channels. Wireless applications include voice, internet access, web browsing, paging, and short messaging, subscriber information services, file transfer, video teleconferencing, entertainment, sensing, and distributed control. Now let's study satellite communication. Satellite communication in telecommunications is the use of artificial satellites to provide communication links between various points on Earth. Satellite communications play a vital role in the global telecommunications system. Satellite communication has two main components: the ground segment, which consists of fixed or mobile transmission, reception, and ancillary equipment, and the space segment, which primarily is the satellite itself. How do satellites work? A satellite is basically a self-contained communications system with the ability to receive signals from Earth and retransmit those signals back with the use of a transponder, an integrated receiver and transmitter of radio signals. A satellite needs its own propulsion system to get itself to the right orbital location and to make occasional corrections to that position. A satellite in geostationary orbit can deviate up to a degree every year from north to south or east to west of its location because of the gravitational pull of the Moon and Sun. A satellite has thrusters that are fired occasionally to make adjustments in its position. The maintenance of a satellite's orbital position is called station keeping, and the correlations and corrections made by using the satellite's thrusters are called attitude control. A satellite's lifespan is determined by the amount of fuel it has to power these thrusters. Once the fuel runs out, the satellite eventually drifts into space and out of operation, becoming space debris. A satellite in orbit has to operate continuously over its entire lifespan. The main source of power is sunlight, which is harnessed by the satellite's solar panels. A satellite also has batteries on board to provide power when the sun is blocked by Earth. Now in the end, let's summarize what we have learned in this lecture. Data that is accurate and timely, specific and organized for a purpose, presented within a context that gives it meaning and relevance, and can lead to an increase in understanding and decrease in uncertainty, is known as information. The two states of a binary device are usually represented by the binary digits or bits 0 and 1. An embedding system is generally designed to survive certain noise conditions. Digital transmission is the sending of information over a physical communications media in the form of digital signals. Phase modulation is a form of modulation that can be used for radio signals used for a variety of radio communications applications.